Okay, got another example of a family of initial value problems. We've basically got a forced harmonic oscillator with our nice initial condition. We're going to vary the forcing function. And what we're going to do is exactly what we did in the last video. We're going to find z, the solution when our forcing function is the direct delta function at 0. And then we're going to use convolutions to find y, the solution when our forcing function is e to the t. And what I'm going to suggest is that at this point you pause the video, try to work that through, and then tune back in to check your work. Welcome back. Okay, so I know that the Laplace transform of z is just 1 over the characteristic polynomial that I get from this left-hand side, which is s squared plus 4s plus 3. Remember, we proved that in general, so we don't actually have to do that work. If I didn't have these nice initial conditions, that would not work, however. Okay, so I'm going to want to take the inverse Laplace transform of this to find z. So I'm going to use the fact that this factors, the denominator is just s plus 3 times s plus 1, two linear factors. So the partial fraction decomposition will just have an a and a b on the top. Now if I clear the denominators, I'm going to get 1 is equal to a times s plus 1 plus b times s plus 3. If s is negative 1, that's going to kill off the a's. I'm going to get 1 is equal to 2b, so b is 1/2. If s is negative 3, that's going to kill off the b's. I'm going to get 1 equals negative 2a, and so a is negative 1/2. So this is negative 1/2 over s plus 3 plus 1/2 over s plus 1. So now I can say z is the inverse Laplace transform. I'm just going to bump these constants on top to the front. Negative 1/2 times 1 over s plus 3 plus 1/2 times 1 over s plus 1. Both of these are just formula 1 for exponential functions. So I'm going to have negative 1/2 e to the negative 3t plus 1/2 e to the negative t. Excellent. So that's my z. Okay. So now, if I'm using convolutions to find y, I know that y is just going to be f star z, which is e to the t star what we just found, negative 1/2 e to the negative 3t plus 1/2 e to the negative t. Okay, now when I'm working with a formula as convoluted as the formula for convolutions, I find it helpful to just write down the formula first and then plug into it. So it's the integral from 0 to t of f evaluated at t minus u times z evaluated at u du. Okay. So here I'm letting f be just my exponential function. So we're going to get the integral from 0 to t of e to the t minus u times z was this sum of exponential functions. So negative 1/2 e to the negative 3u plus 1/2 e to the negative u du. Do remember that we're using our variable for z as a u. Okay. All right, so this is the integral from 0 to t of e to the t times e to the negative u times negative 1/2 e to the negative 3u plus 1/2 e to the negative u du. Now, there are no u's in this factor, so e to the t is constant with respect to u. I'm going to factor that out, and then I'm just going to distribute that e to the negative u. So I'm going to get negative 1/2 e to the negative 4u plus 1/2 e to the negative 2u du. Excellent. All right, so we have e to the t times. Now each of these is a very quick substitution that I'm not going to bother to write out, but basically if here my w was negative 4u, I'm going to need to introduce an extra factor of negative 1/4. So that's going to make this 1/8 e to the negative 4u evaluated between 2 and 0, plus, now here, if I've got e to the negative 2u, I'm going to end up introducing an extra factor of negative 1/2, and so this is going to become actually minus 1/4 e to the negative 2u evaluated between t and 0. All right. So that's going to be e to the t times 1/8 e to the negative 4t minus 1/8. Oops. Sorry, that was 1/8, not 1/8. Don't forget, when you plug in 0, you don't get 0. You actually just get 1/8 times 1. Okay. Minus 1/4 times, now I'm going to get e to the negative 2t minus e to the 0 is 1. So let's do some distributing. Let's see, I think I'm going to distribute the e to the t here. Well, actually, let's do this first. Let's distribute the 1/4. So minus 1/4 e to the negative 2t plus 1/4. Okay. And then I can combine the 1/4 with the negative 1/8. So I'm going to have e to the t times 1/8 e to the negative 4t plus 1/8, that's the sum of those two constants, minus 1/4 e to the negative 2t. And now let's just distribute that e to the t. So 1/8 e to the negative 3t plus 1/8 e to the t minus 1/4 e to the negative t. So that's going to be my y. That was my solution when the forcing function is e to the t.